Alright, so the purpose of this video is to do a couple of examples where we're doing a dilation on a coordinate grid. The first example is going to be one, or the first couple of examples are going to be ones where the center is at the origin. So we're going to dilate from the origin. So this one says dilation of 2. We're going to read that as dilation of the scale factor of 2. And my center is going to be at the origin. All right, a couple different ways to envision this, and probably the simplest way is to just say, well, look, here's my center, here's point G. G needs to move twice as far away from the center as it is right now. I can use my grid to count where G is in relationship to the center. So it's over 1 and up 2. To double that distance, I'm going to go over 1 and up 2 again. All right, and there's my new point G. All right, and then I can just repeat the process with point H, which is down 1 and over 1. I'm going to do that again, so then now I've done that 2 times, it's twice as far away. E is just 1 to the left, so it's going to move over 1 more to the left. F is left 1 and up 2. I go left 1 and up 2 again, and there's my new point F. There is my new figure. Okay. Now, one cool thing that happens when you dilate from the center on a grid is that the coordinates change. You can find out what the new coordinates are just by multiplying the original coordinates by the scale factor. So, for example, notice that G is at coordinates 1, 2. G prime is at coordinate 2, 4. And then remember the scale factor here was 2. So 1 times 2 is 2, 2 times 2 is 4. The same thing happens for every other point. Notice point E is at negative 1, 0. And E prime is at negative 2, 0. Each of these points, if I multiply them by the scale factor, I get the new coordinates. So negative 1 times 2 is negative 2, and 0 times 2 is still 0. Okay? So that would be an example of one that's getting bigger, doing a dilation from the origin. Let's do one that's going to get smaller. So this is a dilation of 0.25. So every point needs to be 0.25 as far away from the center as it is right now. So one helpful thing for me is to think of the scale factor as a fraction. 0.25 is 1/4. All right. So if we look here, F is 2 units away. If I do 1/4 of that, it's 0.5 units away. Okay, E is over 1, 2, 3, 4, and down 1. So 1/4 of 4 would just be 1, and then 1/4 of 1 would be 1/4. So there's point E. And then G from the origin is left 1 and down 1, 2, 3. So left 1, 1/4 of that would be left 1/4. And then 1/4 of 3 would be 3/4. So that point would be right there. And that's G prime. Okay? And then there is my new figure. All right, and one quick check after this is like, is it the same shape but just 1/4 the size, which this one it looks like it is. Okay, now I'm going to do a couple examples also that are where the center is not at the origin. The only drawback to this is that you can't just multiply the points, right? Because since we're not going from the center, the points are going to be shifted up a little bit. But one thing I want you to notice, actually, before I go over there, look back to here. Notice how before, when we did this in free space, everything lined up and moved along lines. Same thing here, right? These points are moving. F has to move along that line from itself and the center where we're doing the dilation from. All right, so let's do one that's not centered here. So we are going to do this one by a scale factor of 4 from the point 0, 3. All right, 0, 3 is right there. Okay? Now, if you want to, you could just sort of like sketch in the line that that's going to go through, right? So I don't have a ruler with me. Okay, but it's going to have to move along that line. And then this point, I can do the same thing, right? Just draw a line through there. And then same thing with this point, draw a line through it if I had a ruler. And then that's going to sort of help me make sure I end up on the right point. But I can also just count the grids. So this one is left 2 and down 1. Okay, if I do that times a scale factor of 4, I'm going to go left 8 and down 4. Okay, so that's where my new that point moved to. This point is left 1, 2, 3, 4, and down 1. 4 times 4 would be 16, and then it's going to be down 4. So 1, 2, 3, 4, 7, 8, 9, 14, 15, 16, and down 1, 2, 3, 4. Okay, this point moved to right there. This point is up 2 and left 3. So I'm going to go up 8 and left 12. 1, 2, 4, 5, 6, 7, 8, and then left. Right there. Okay, and there's my vertices of my triangle. When I connect those vertices, I get my dilated figure. Okay, looks like the same shape, 4 times as big. In fact, on the bottom we can confirm that because this side is 2 and this side right here is 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's do one more. All right, so this one we're going to dilate by a scale factor of 1/2, and we're going to use negative 2, 1 as the center. So there is the point, negative 2, 1. That's the center of dilation for this figure. All right, so now I need all these distances to get cut in half. So this point right here is left 1, 2, 3, and up 1. Half of that would be 1.5, and then up 1/2. This one is right 1, 2, 3, 4, and up 1. If I cut 4 in half, I get 2, so it's going to be right 2. And then if I cut 1 in half, I get 1/2. So there's up 1/2. Okay, this point way out here is right 1, 2, 3, 4, 5, 6, and down 1, 2, 3, 4. 6 cut in half is 3, so 1, 2, 3. And then down 4 cut in half would be down 2. Okay, so there it is. My new shape. And if I look at it, it is half as big and it's the same shape. All right, hopefully that's enough examples so that you can see exactly how dilation works on a coordinate grid. In a lot of ways, it's better than doing it in free space because you don't actually have to measure out the stuff. You can count, and so it's a little bit more exact. It's easier to see the points, other than the times when like you have a point that's a half and it doesn't go exactly on where things cross on the grid. Hopefully that's enough to complete your assignment, and we can go over questions next time.